So on this webinar, we are going to use Adzuna dataset. I'll briefly show you all the information. So Adzuna is a job aggregator website having about 95 job listing coverage in UK. So it's really easy to use. You just search by job, company, or location, and you get an aggregation from different sites listed there. So there are two data sets. One is open, collected using Adzuna API. I added all the links in the presentation, so you can follow along as well. So if you wish to collect open Adzuna dataset, you can register for an API, receive the key, and just query the data yourself. So in this data, it's free and open data. To reduce the size, data has been selected to location area 1, having Scotland value. It's only sample data, mainly because of its size. I would also like to introduce a licensed dataset available for academic use at Urban Data Center website. Oh, it's a click. So this dataset is clean, deduplicated. The only thing you would need to apply for data to get access. So the difference between these two data is one is open. It's messy, let's say, due to its nature of scraping, but there's a work that could be done with it to derive the insights. And there is a licensed dataset available for academic use, which has been deduplicated, cleaned up, and nicely formatted. The other thing is in the data, there is a description field containing information about the job ad. And in open data, it's truncated to 500 characters. So quite often it just, only a fraction of the job ad itself. Right, in this lab or training, we are going to use GeoPandas, which is an open source project, which extends Pandas frame, series and data frames to GeoSeries and GeoData frame. And the main difference between those two is that GeoData frame has a special column geometry. Again, I added link for documentation if you want to explore further. So let's start to open the data, and I'm going to run in this session alongside with you. So on this step, we are going to import pandas to open our data set. And the data provided, the very first data provided is in Parquet format, which is an open source file format, which is designed to efficiently store the information. And I have included more information about how it works, its specification, and other things. So in this lab, we are using it because of the size of the data. So it was just more convenient to pack it in a Parquet and share it with you. Let's load it. So I'm specifying my data source. And now I'm going to open it. Right, let's do it like this. My source and convert it to Pandas GeoData frame. So, let's have a look at the data frame. So this is what our Adzuna data looks like. It does have information about the job title, its category and tag. This is, by the way, created by Adzuna. It's, there are some categorization of the data available in open data. The dataset has information about contract type, well, in some cases, information about minimum salary, description. As I mentioned before, it's truncated to 500 characters, at date it was created, and location information. So in this lab, we are going to use longitude and latitude to make this data special. So before we do any kind of GIS analysis or GIS work, let's just look at the data and try to plot it. So in this lab, And on this step, I'm going to use Seaborn library. For visualization, you would see why shortly. It has very nice joint plot type of visualization to really showcase geographical data. And I'm going to use Contextually. It's a library which provides background mapping. So on this line, I specify that I want to create this type of plot called joint plot, where X would be a longitude and Y a longitude from my data frame. By default, I think the color is blue, so I changed it to red to make data more visible. On this line, I'm adding base map from Contextually, and I'm saying that I'm adding it on the same plot. I'm specifying CRS. So I'm going to talk about CRS, which stands for Coordinate Reference System, in more details later. And I'm specifying the source. Source is the kind of type of background mapping I would like to see. Again, I'll talk more about it later and provide a few examples of what could be there. Alpha is set to 0.4 and alpha is a transparency. Again, I've made on this lines, I made plot slightly bigger than it is by default, so you can see data better. So if you're familiar with kind of UK geography, you know that this area in red is Scotland with several job ads out. Well, they have this kind of outliers, let's call them outliers. They do have Scotland as a value in location, but their coordinates are set to somewhere else. We'll remove them later. And if you see here, joint plots shows where the kind of maximum distribution of the odds are. And if you kind of create this intersection, you would see that it's Edinburgh and Glasgow. And the probably third popular location is here in Aberdeenshire. Right, but important to say that at this stage, this data is not special data yet. To make it special, we are going to convert data frame into geodata frame, so we are able to perform geospatial analysis. We're going to impact GeoPandas, and the convention is to shorten the library name set. So we're going to import GeoPandas and SGPD. Again, GeoPanda is a project which allows to work with geospatial data in Python environment. On background, it uses Shapely library. I've added the documentation here, so if you click a link, you can read about it later. And it uses matplotlib for plotting. Right. So let's import matplotlib as we're going to use it for plotting GeoPandas. And in this session, we are going to use with points and polygons, so I'm importing them as well. Right. So now we need to create our geodata frame based on our available X and Y. And the convention really, the command is GeoPandas create points from XY, which kind of says everything for itself. So let's do this. So in this step, I'm creating geodata frame and I'm calling it GDF. I'm saying GeoPandas data frame command using my DF data frame, the data job parts data loaded on the previous step. And for geometry column, we are going to use a longitude column and a latitude column and create points based on them. Right, let's see our data. So we have exactly the same data as before. If you noticed on the previous steps, when we looked at the data, we had only 23 columns, and now we have one extra column called geometry, which is a point, and it has information similar to what we have here. So now we have a spatial data set. Let's check coordinate reference system. We could have specified it on a previous step by, if it's not specified by default, it's set to none. And this section, I'm going to talk very, very briefly about map, projection, and coordinate reference system for those who are not familiar with this kind of concept. which is very, very crucial in JS world. So map projection, in a very simple term, try to transform the Earth from its spherical shape to a flat, well, planar shape or kind of flat map. And coordinate reference system, CRS for short, then defines how this two-dimensional space projected on a map in your geographical system relates to a real place on Earth. So decision of which map projection and coordinate reference system to use depends on the region and, well, country. I've included a source link where you can read more, but please bear in mind that CRS are very, very important for JS. For JS. So I have included a few visual examples just to showcase that depending on the choice, you could have different distortions. So in this case, it's distortion by area. And there is another example just to illustrate how the shape changes. Well, it could be also distances and angles changing depending on the projection, but what you see on the screen would change based on what you specified. Again, there is a source to check and maybe learn about it a bit more on your own. So now we are going to set coordinates to WGSH4 using setCRS function, which takes APSG code, which stands for European Petroleum Survey Group, and kind of value of the system. So for WGSH4, the value of APSG is 4326. And I'm printing it as well just to check that it worked. So I've also included for you several links, quite useful, I think. So one is special reference where you can find, so there are many codes and references, coordinate reference, so we'll just open one. So it does contains bounds, well, link on a Google, and the other one is also quite useful. It I'll just open it. It does have also visual representation of what you would expect your data to be like after you project it. And also it does contain transformational values. So let's move on. So now we set up our coordinate reference system and we have our geospatial data. Let's do some visualization. So we are going to use matplotlib and the function .plot. And by default, the map in GeoPandas is created based on geometry column. Let's run it. So it might take a while. What I'm saying is I want to plot my geodata frame. I want my dots to be of the red color and I want it to show. So if you see here, it's a small plot, but you can see the outline of the skeleton here, similar to what we've seen when we were visualizing data using just X and Y and seaborn, right? On this step, I would like to open to show how to open different file formats of spatial data in Pandas. So this step, we are going to load boundary of Scotland using open and free Ordnance Survey data boundary line, and which is available for download for everybody. So it's free download here. And it is a collection of data available, trying to find the description. So it does contain information about boundaries of civil parishes, wards, communities, electoral divisions. So it does contain a lot of information and is available for download. To read the file, you just need to specify GeoPandas read file, and what it does, the library reads the data and it returns it as a geodata frame object. I'll run it here. So I'm calling my new geodata frame OS data, and I'm saying the read file, which is saved in your data folder. So it's district below unitary shape. So the full data set is provided is GeoPackage with many layers in it, but to reduce the size and sort of make it easier for you to work with the data, I converted it into a shape file. But if you decide to load full dataset, please you uncomment this line and use this. So very similar, we are reading the file in full dataset H2 package and its name, and we specify the leg we need to be loaded. So it would provide the same result. Right, let's check coordinate reference system. So this data is projected dataset to British National Grid, PSG code 2770. Right, let's visualize our data sets together. So I'm going to plot my OS data and my Adzona job listings together. It might take some time. Again, I specified my Adzona data to be red. And if you see it, it doesn't look right. So we have our UK and our Adzona data here, over here, but we would expect it there. So there is a kind of one of the typical and common problems which could occur when you using GeoPandas is a mismatch of projection. If you remember, our geo.frame was in WGS84 and OS data is in British National Grid. So if you visualize your data and see something like this, the first thing would be to check the projection. So on this step, let's make the plot bigger and fix the projection issue using toCRS command. So I'm going to run it. So on this line, I'm setting my plot to a bigger size, and I'm going to reproject my boss that sets to Web Mercator to align it with background mapping. So on this line, I'm reprojecting my OS data using command toCRS, specify new coordinate reference system. Similarly, on this line, I'm doing the same with my Adzona data from the geodata frame, and I'm setting color red so we can clearly see it. And on this line, I'm adding base map. So now our visualization is better, so data aligned. And what I wanted to talk about next is contextually based maps. So there are different ways you can use reprojection and align it with base map. So just a reminder that on this step, we reprojected both layers and didn't do any reprojection of the base map, but it could have been done in different ways. So we could have reprojected only one layer to match the coordinate reference system of another one, and then specify the same PSG code in our base map. And we would, it's the output which we would expect. So the data is at the same location, but it is visualized in a just slightly different way. What I mean by this, just try to compare this picture and this. So data is the same, just different coordinate reference system and slightly different transformation. So now I'd like to show you available backgrounds. So if you specify contextually provider keys, you would get a list of all available background map providers. So and then if you add contextually providers and instead of key name add something like here and set dot keys, you would get a list of this background mapping visualization of different styles available this provider. So in this example for provider here, we have this many different styles available for you to use. Right, special join. So this is quite popular operation in JS. I've added link how it works in GeoPandas. So here it is, special join, it's different arguments. Again, it's something for you to have. So as always, let's look at the data. And on this step, we are going to remove outliers, but not outside of Scotland. I limited it, and to make it smaller and faster, we're going to remove everything outside of Glasgow. So just a quick recap. So our geodata frame with Adzona listing contains 24 columns now, 23 of which is Adzuna data itself, and the one is a geometry we created. Right. I'm going to subselect my coordinate survey data only to have Glasgow data set, and I'm going to call it Glasgow. Right. Let's just quickly look what it looks. Again, if you're familiar, this is a Glasgow boundary, just a visual check. Let's check what coordinate reference system it is in. So it is in WebMercator. If you remember on the previous step, we projected OS data and Glasgow geodata frame kind of inherited it. Right, let's make special join. So to make a join, we need to specify our geodata frame we like to join. And in this example, we are going to select everything which falls within. And if you see, we got an error. And what do you think caused an error? So if you read user warning, it says that CRS mismatch between left and right geometry. So, and it says this, that our left geodata frame is in WGS84 code 4326, and our Glasgow data frame has a PG code 3857, which is WebMercator. So because there are different projections, GeoPandas cannot figure it out and throw an exception. So what we need to do is to project one of the layers to match the projection of another. Let's run it. It might take some time if you run it on your computer. So again, to remind you that we are going to select all the job paths within the Glasgow. Let's have a look what we've got. Well, we're gonna specially join our Adzuna dataset and Glasgow boundary. Right. I'm going to check the length of my join. So now it's quite small and manageable dataset, and I'm going to remember this number because I'm going to use it for something else as well. Right, let's check what we have inside. And first thing you would notice that now we have 41 columns. So what happened here, our Adzuna dataset has been specially joined with Glasgow, and all the records received information from the other layer related to this location. Well, in this case, it's only information about our Glasgow. So the same information for all the points, but it could be used in a more powerful way, which I'll show you later. But important things to note that to take from it is that by joining two, especially joining two geodata frames, we receive information from both of them. Right. On this step, I really wanted to show that you can use your geodata frame in a similar way as your data frame, and you can use typical functions. So here, for instance, I use group by a command to find most paid categories by finding average minimum salary and then sorting values by this salary. So in this step, we just kind of did a summary of our geospatial data frame or geographical data and received some statistics. Right, let's quickly visualize data, and I would like to introduce you on the step GeoPlot, which is a fantastic library for geospatial data visualization. I'll quickly show you gallery just to introduce different visualization styles and techniques available from here. Again, please have a look when you have some time. And as always, we need to import this library. And here I'm going to use point plot, where my of color would depend on the value in salary min column. So the other parameters is just legend true is to have those legend here. Edge color is set to light gray, but you cannot really see it. So it's edge of the point and it's line width. So we do have visualization, but clearly most of the values fell in this region, and we cannot really see the difference between different areas of Glasgow in terms of salary min. So let's, to fix this or to enhance it, I'm going to use Map Classify. It's Map Classify is a library which provides classification schemes. So there are different parameters. You'll see. So I'm going to import this Map Classify library as MC, and I'm going to use scheme quantiles and my salary min column from join. Now, as on the step before, this part is the same. The only thing I made in here is I'm specifying the scheme I'd like to use. And now, so the legend changed, but now you can see that the data has been reclassified, and now we can see the distribution based on the salary min column. Again, there are many schemes and classifications types available. It's very, very powerful to locate and quick and nice visualizations. Right. The other geospatial function I'd like to introduce is a clip. So Japan does clip similar to what you would expect to get in traditional JS. So one layer is clipped by another based on the geometries. Again, very important, both layers must be the same coordinate reference system. So for that reason, let's check what we have now. So one of our layer is in Web Mercator and the other one is in WGS84. So let's reproject both layers. Web Mercator. Actually, now I'm thinking we do not need to reproject one of them. We need to reproject only one of them. Yes, and let's do the clip. So we are going to clip our Adzuna job listings stored in GDF by the Glasgow boundary and remove everything else outside. So let's check the length of our data set. So if you remember, it is exactly the same number as we have when we were joining the data. It's worked quite similarly. Let's look at the clipped geodata frame. And again, there are only 24 columns. So the way clip work is it subselects kind of all the features within other features. So what we got here, we got our Adzuna job ads subselected or clipped only to be within the Glasgow. So no extra additional information is added when using clip. Now let's plot the data. So again, I'm specifying my figure size on this line. I'm plotting my clip geodata frame, my Glasgow geodata frame, setting some transparency so we can see both data set, and I'm adding my base map. Now I'm using OpenStreetMap Mapnik. So this is what we've got. Again, if you see, no point is outside of the Glasgow boundary. So on this step, I just really wanted to show you that using join and clip in this way provided us with the same result, and assert works the way if you run assert statement and it doesn't return anything or returns true. If it doesn't return any output, it means the statement is true, and if it throws an error, it means it's false. So in our case, both those partial functions provided the same results. I'd like to explain this side. So when you work with geoplots, quite often you could come across some clearly wrong result, but do not get any error. And it's kind of a little hack or hint. So in GeoPlot, coordinates needs to be within this kind of frame. So they should be between -120 and 1 + 120. I'll showcase what I mean here. So I'm going to create clip reprojected. Well, I'm going to create new geodata frame by reprojecting available clipped data frame. And I want to show you bounding boxes of our newly reprojected data frame and our existing clipped data frame. So if you see this geodata frame kind of bounding box are within -180 and +180. And because of the different projection of a clipped data frame, they are kind of out of this limits. Again, a bit of explanation. So if you plot our clipped geodata frame, because it does fall within those bounds, you would get some visualization. So in this case, this is our clipped geodata frame where size of the point depends on the information stored in the salary mean column. Limits just specify minimum and maximum size of the points. So figure size is just the size of the plot. Alpha is the transparency. Legend is set to true. Again, probably it's better to reduce the size from 50 to something else, so it does fit better. And on this line, I'm also adding my Glasgow boundary on this plot. Now let's have a look if we use clipped geodata frame, which bounding box are outside of those values. And see, you have only Glasgow outline, but nothing from clipped data frame, and it doesn't kind of throw you any error. So if anything like this happens when you're using GeoPlot, just bear in mind that you might need to use different projections. So your bounding box is within those limits. Just some hint I wanted to share. Right. On this mini example, we would look into transformation between geodata frame and data frame. As I mentioned before, you can use common or most pandas functions in your geodata frame. And I'm going to add in another data set. It is data zone boundaries. I've added the link here. So it's an open data set containing data zones, which, if you're not familiar, it's a kind of statistical area in Scotland. So the data provided on website comes in a shapefile, but I have converted it to GeoJSON just to show how easy it is to open this file format, and it's quite typical file format kind of available and used. So again, the data zone boundaries were clipped for Glasgow just to reduce the size. So let's open it. So similarly, we just say in GeoPandas, read file and specify the file location. Let's check coordinate reference system. So it's British National Grid, port 2770. Because I'm going to use with my geodata frame containing Azuna ads, I want to check what it is now. So after several projections we made, so it is in WebMercator code 3857. So let's convert our geodata frame to match data zones, specifying to CRS command and the British National Grid code. Let's look at our data zones. So you see, this is a Glasgow boundary and small tiny polygons inside, which we're going to use in our sticks. So what I want to do is to make a special join again, but this time I'm going to use my Azuna data and my data zone, assigning values of a data zone to every point of Adzuna job ads based on their location, saying that operation we are going to use for this is the point should be within the polygon, fully within. So depending on your spec of your computer, it might take faster or longer, so be patient. Let's have a look at the data. So we do see that we received extra columns. Let's have a look. So we have our Adzuna data here and data zone information attached to it. So, but just important difference, when we did the join with Glasgow, we only received one set of values for every Adzuna point. So those are going to be different for every point, or for most of points. Right, let's find average salary advertised per data zone. And to do this, I'm going to use group by. So I'm going to use to group by my data set by data zone name, and I'm going to find average value of salary min column. Let's have a look. So our data would look like this. We would have data zone name and average information of salary min. And because I'm going on this step, I'm going to rename my columns because it's not really a salary minimum anymore. It's average salary min. So I'm going to rename the column just to make it clear. And now let's join our geodata frame data zone with this sort of statistical information of salaries. So I'm going to purchase data set based on the name. Let's have a look at the data. So now we do have name of the data zone, average salary, and information of the data zone. Note here, it does contain geometry column. Let's check the type of our salary data zone. And our Panda says it's a data frame despite having geometry column, and it is recognized as a data frame. So let's plot it to verify that. And you see, it's not our geographical representation or a map we see it. So it's some plot. So Pandas clearly recognized our salaries DZ as a data frame. So to do that, we need to say that or create a new geodata frame salary DZ, saying that our salaries DZ data frame we created on previous step has got geometry, and this geometry is called geometry. So pretty much we specify this. Please use this column geometry as our geometry. Now let's see columns. Yeah, so we still have geometry, just to check. And let's plot our new geodata frame to check that we do have a map now. So we do have a map now with some empty values. So these empty values or empty spaces are the data zones which did not have any Adzuna job listing. So there is no average salary average salary available for those data zones. So at the end, they just disappeared from the dataset because there are no values for them. Right, let's do some complex mapping. So just wanted to say it's not normalized data for analysis, just an example. So for our plot, we are going to use salary min column. Color map is yellow, green, blue, but you can use anything else. Figure size is set up on this line, and for scheme, I'm using contours. So this is our distribution of average salaries between data zones in Glasgow. Again, blank spaces are those data zones where no information was available. And here I would like to show you a link for color maps available in Matplotlib. Give me a second. So this is how they look and what's available, and the name of them which you could use in your code is just provided on the left-hand side. Right, let's do some cartogram using GeoPod, just to showcase that it does contain lots of visualization. So I'm going to convert my Savaris data zone geodata frame to WGS84. The scale of my data would depend on information or on the value stored in the Savari min column. Because H cover is the cover of those polygons inside. The cover is also depends on the value, and a color map used here is red. Let's try to do something bright. This should work. No, focus. Well, not much better. Well, yeah, you can play with it to make it brighter. I'm not sure what you see on your screen. On mine, it's quite pale. Let's try something else. I think this one is better. So you can see that polygon size depends, and its color depends on the value in the Savari min column. Another quite popular type of visualization you probably could have seen in the internet, just showing dependency of this true size and kind of some value, and the size represented by some value. Right, and as a last step, I want to show how to export your data from your geodata frame outside. And really, it is just to use a command to file and setting the destination. Or if you exporting it to a database, you would need to specify the connection details, location, well, connection details schema, and really what you want to export. Again, more information is if you follow this link. So I'm going to export my flipped geodata frame to file. By default, it's shapefile, and there is an important warning that shapefile does only support 10 characters in the columns name, so all the names would be truncated. It is, well, it is no limitation of a shapefile, so please bear in mind that if your geodata frame has some very descriptive long column, it probably would be better to export it into some other format. Right. I'll probably show you how our data looks like. You give me a second. So what I'm going to share some other screen. So it's gonna be QGIS, kind of open source JS, traditional JS software. And I'm going to open my exported Eclipse geodata frame so by just drag and drop. So it's similar to what we've seen in our notebook. Right, I'm going to share my notebook again. And this is it. Thank you very much for your participation. Please visit our website to find out more about our upcoming webinars. And I'm ready for questions and answers, if you have any. Thank you. Right, so I'm going to open chat and check if there are any questions. So yeah, I see that quite a few people are asking where to get the data. It's been uploaded to GitHub. It's available for you, and I'm going to add this presentation, this slight modification to what you have got on GitHub. So I'm going to add it on a later date, so it could be accessible for you quite soon.
Thanks, Nadia. Yeah, and I am also posting the link that they usually put the past presentations and resources afterwards. Yeah, you wait a few days, I think. Yeah, it's here.
Right.
Okay. Yeah. Maxwell has a question on choropleth maps.
Choropleth maps, yes.
Yeah, can these choropleth maps be made interactive? Yeah, I would also want to know that.
Yes, but it does. It does require different libraries, and it's kind of another complexity. I did not show anything in this lab just to keep it simple and introductive. But yeah, it does possible. Just different set of libraries to use. So something like Bezier maybe, or Dash. So both of them can display geographical information easily, but do provide some interactivity.
Yeah, and I was wondering, earlier, you mentioned something about the boundary files pretty early on in the presentation. Could you also share those links?
Right. I'm going to share my screen again. So in the chat, Chaoban has sent you a link to GitHub where you can find the data, the exercise itself. So it's an exercise folder. So if you open this Python lab, you would have, so because I have it here, you would have this notebook with all the links attached. So please have a look there. I'm trying to find this presentation and notebook. I'll update on GitHub later. And it's pretty much the same as what you have received with very tiny modifications and additions. So please refer to GitHub. In the notebook, if you scroll down, you would have all the links, all the data sets, so it's boundary line. I think this is the one mentioned. Oh, as well, I can send those in the chat. To stop sharing, but this is it. And there are many open data sets available on Open Survey website, something like Open Roads, Hotpoint, and ZoomStack, which are fantastic for visualization to and to work with for geospatial data analysis. They're not very detailed in some respect, but very useful as data sets to use when you are learning kind of new libraries or a tool. Are there any more questions? Does the projection used tend to vary by country? Well, the question is, does the projection used tend to vary by country? Well, yes, it does. Typically, every country has its own projection. Which is selected based on the best fit of this area. And there are different projections which preserve either directions, angle, or areas. And again, those three could be used depending on what you want to have less distortion of, let's say. And the second part of, so yes, different countries tend to have they do have different projections, or does that tend to be a standard reference? So data collected via GPS devices, mobile phones, are provided in Word, WGS. Absolutely forgot what it stands for. H4. So it's World Geodetic System. Yeah, H4 is the year it was created. So this is quite popular CRS to use for this type of data. The type of data which you see, something like Google Map, it's called Web Mercator. It's slightly different transformation than the code. But what I wanted to say, if you know if your data is projected to some CRS, it's very easy to reproject it to some other. If you know so where your data is and what projection it is, you can easily reproject it to something else. So for Britain, all government data sets are provided in British National Grid, but again, if you need to add additional information from the internet, you can easily reproject them, those data to WGS84 or the other way around to British National Grid. I hope I explained it well. It's quite a complex topic, so I would really suggest to scroll through the links I provided and have additional read to understand it better. It's quite a complex topic. Thank you. So as I mentioned before, the video or recording of this webinar would be available in accessible format on a later date, so you can review it. And my presentation / notebook would be uploaded to GitHub as well. So I think this is it. Thank you everybody for joining. Thank you for all the questions. If you're interested in the data, you can contact UBDC or register with Azuna for the API. And I think in a few weeks' time, there's going to be a call for interest in licensed Azuna. That's it. Thank you, everybody.